Hey guys, in this video I'm going to be talking about good sampling techniques. So what is good sampling techniques? So anything that is random. So includes random chances. So random sampling uses a method of chance. And this method of chance identifies which members are part of the sample from your population. So your population, let's talk about that for a second. Your population and your sample. Okay, so your sample represents the population. So let's say we had, you wanted to find out how many people in the school liked this new program where students could get coffee in the mornings for free. So you decided to basically select randomly 10 students in each grade to find out how many does the school like coffee or not in the morning. So your population would be your entire school, so every student body in the school. So every student in that particular school, in that school only, in the school. And the sample would be 10 students from each grade level. Okay, so you're randomly selecting these 10 students from each grade. So I go to ninth graders, let's say ninth graders, I randomly select 10 ninth graders, and then so they become part of my sample, so I have 10 randomly selected. Then I go to the 10th grade, and then I select 10 random students, and then I do the same thing for 11th and 12th. So in total, I would have 40 students in my sample. Okay. So let's go on to the types of random sampling. So in random sampling, we have simple random sample. So simple random sample. We use the abbreviations SRS, simple random sample. And this type of random sampling is in which a sample of size n, so basically we can have any number, the sample size could be any number. It could be the sample could be 2, it could be 2 million, it could be 357, as long as it is less than the population. Okay, so and each group of individuals has the same chance of being selected. So random, okay, so two things, any sample size, as long as sample size is less than the population. And we also have to make sure that, each member has equal chance. Each subject has equal chance. Okay, so let's take an example. So how can you perform this this method of sampling, this SRS or simple random sample? Well, one, you could use a random number generator. So let's say your classroom has 25 students and you want to select 3 students to see what they think of the lesson. So you take a number generator, set it equal starting from 1, and then run it to, set the max limit to 25 students, and then you hit run, and then, you'll get maybe the number 7, and then you hit run again, and then you might get the number 25, and then, you can get the number 16. So it's completely random. Sometimes you might get the same number twice. In that instance, so I hit the random number generator, I might get 16 for the first time, and the second time I could get 16 again, because the chance of getting 16 is the same as the first time. In that case, just ignore it and then rerun it to get a different number. So random number generator. The second option is through a paper, slip, and hat method. So in this instance, you write the names of everyone in your classroom or number them, and you put all the slips into the hat. And once you do that, you close your eyes, shuffle, toss the hat in the air, make sure it's all mixed up. Then randomly, with your eyes closed, you're going to pick a slip of paper and you're going to say, okay, I got the number 8. And you're going to put that number 8 back in the hat once you've recorded the number 8. So you're putting the 8 back because you don't want to, lower the risk. The higher, or you don't want to make the probability of getting the next number higher. So let's write it out. Let's say you have 25 students, right? So the chance of getting, the number 8, for example, is 1 out of 25. So let's say you took the slip and you put it on the desk. The number 8 is on the desk right here. So now you have 24 in the bag, and then the chance of getting a different number, so let's say it was 22, that's become 1 over 24, which is greater than 1 over 25. So paper, slip, and hat method. So make sure you're cognizant about that. Okay, moving on to our next type, which is systematic. So let's use a different color. So systematic. In this scenario, you are selecting the first person you select from your data is completely random. So, you take 1 to 25 and you select, or you hit run and get a random number, or you use one of these methods to get a random number. So let's say I get the number 12. So once I get 12, I select a number. So let's say I pick, out of 25, I want 3 students, and I started with the number 12. So I'll choose the number 4. So I count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 18, okay. So number 12 is what I picked randomly. So then I count by 6. So 4. Okay, so I count by 4. So 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. Until I get 6 people in my sample. So I have 4 people. So then 1, 2, 3, 4. And then I have 5. So 1, 2, 3, 4. So now I have 6 people in my sample, and those are 3, 7, 12, 16, 20, and 24. So that is systematic random sampling. So the first subject is random. Subject is random, and then you go based on every nth term. Count by every nth term. Okay. Now, let's go on to our third type, which is stratified random sampling. So let's take an example of this. So let's say we wanted to know, what the general population in the United States thought about energy drinks. So we can't just ask what teenagers think. We can't just ask every single 35-year-old. We can't ask every age group, because every age group is going to get a different response. So what we could do is categorize people based on their age group. So maybe 0 to 12, maybe not 0, but 5 to 12 in one age group. Then 13 to 22, then 23 to 45, 46 to 61. So you've taken a big population and divided them into these subgroups based on age. So the general population is basically every single person in the United States, and you've taken each person and you've categorized them based on their age group into these subgroups. So these are called subgroups. And in each subgroup, you take, let's say, 30 people. So this would be 50, maybe. You can take a different amounts. You can always take the same amount as well. It doesn't matter. You can do it based off proportion. So let's say we had more people in this group. We might take, instead of 30, we might take 70. Or let's say it has to make sure that your sample represents the population. That is very important. So moving on to our last type, which is cluster sampling. Now, let's talk about cluster. So let's say we had a school and there were 90 ninth graders, there were 100 10th graders, and 110 11th graders, and 120 12th graders. So this is the population. So these numbers right here represent the population. So our sample for a cluster sample would basically be selecting everybody in a random cluster or a random subgroup. So I take a random number generator from a 1 to 4, and let's say I click it and we get the number 3. So let's number them. So 1, 2, 3, 4. So I get the number 3. So I'm going to select everybody in 11th grade gets to participate in my experiment or observation. Then I click select to run the random number generator again, and I get the number 1 this time. So the 9th graders come into my observation or experiment as well. So these two, so 90 plus 110 students will become my sample. Okay. And the 10th graders and 11th graders don't be part of the sample because the number generator did not select 2 or 4.